Okay, so here we go. 8 root 6 plus 6 root 6. All right, so we're in 8.4. 8.4, so remember what we're doing with roots in this chapter. We're learning how to do everything with roots. We've learned how to multiply them, divide them. Now we're adding and subtracting roots. So how do we add and subtract roots? What do we do? Just add the numbers in the front. You know what it's like? It's going to be 14 root 6. It's like 8x and 6x. Does that make sense? It's just like terms. It's like roots. So when it comes to adding, subtracting things in the root world, you just add the numbers in the front, you leave the root. It's just like terms. Which means, though, that if the roots are different, you can't add them. Am I making any sense? So, for example, if they gave us 8 root 6 and 6 root 7, we would just say you cannot. They're unlike. It's like 8x and 6y. Does that make sense? So if the roots are different, it's like having different letters. You can't do it. So when it comes to adding and subtracting roots, it's all about like roots. If the roots are like, you can add and subtract the numbers in the front. All right. Four roots of x minus 2 roots of x. Try that one. So what's the deal? 4 roots of x minus 2 roots of x? It's just 2 root x. I kind of scribbled that out. But that's it. Good? Five root 20 plus 1 root 5. Try that one. Can you add those? They're unlike roots, right? Can't add a root 20 thing with a root 5. They're different roots right now. But what can you do? Simplify. Yeah. Break them down. Do the 2 for that. 20's got pairs in there, right? So simplify that 20 and something good will happen. You'll make them like roots. So take it from there. Start by simplifying that 20. One more time?
Does it matter if the 1 is in front of the square root of 5?
Oh, it's optional. Yeah. 1 root 5 or just root 5. Same thing. Okay, so here we go. So that 20 is 4 times 5. And the 4 is 2 times 2. So break down the 20. You got 2 2's inside. So that'll send 1 2 outside, which will hit the 5 that's already out there. You with me? Whenever something comes to the outside, it's going to multiply, right? It's all multiplying. It's going to multiply the thing that's already on the outside. So we'll get 10 root of, what's left inside? Just this 5. Plus 1 root 5. Is that good? Now they're like roots, huh? Now we can add the numbers in the front. 10 roots of 5, 1 root of 5, 11 roots of 5. You got to add the numbers in the front. Does that make sense? Questions on that one? We good? Root 80 minus root 45. So try that one. So break down that 80, break down that 45. And they should become like roots when you do. All right, did you do it? Break down that 80. 8 times 10, 2 times 4, 2, 2. The 10 is 2, 5. Good? So there's the breakdown of the 80. Well, what do we got in there? We got 2 2's here and 2 2's there. So 2 2's in, 2 2's in. So each sends 1 2 out. That was a times dot there. 2 times 2 on the outside. So that's 4 square root 5. All right, and then the 45. Let's break that one down. 5 times 9. The 9 is 3 times 3. 2 3's in, 1 3 out. So it'd be minus 3 root 5. We good to there? 4 roots of 5 minus 3 roots of 5 is 1 root of 5, or you could just say root 5. It's the same thing either way. Is that good? Does that make sense? Same thing either way on that one? Questions on that? Is that good? It's all about the 2 for 1. All right, I'm going to move on. I keep feeling like I just keep saying 2 for 1, 2 for 1, 2 for 1. Five root 27 plus root 75 minus root 12. Same thing, break them down. Okay, 27 is 3 times 9. 9 is 3 times 3. 2 3's in, 1 3 out, 1 3's left in. So 15 root 3 for the first one. Then the 1 in the middle is what? 3 times 25. 3/4 makes 75 cents, right? And then 5 times 5. So 2 5's in, 1 5 out, and then the leftover 3 stays in. Good. As opposed to what? Oh yeah, I would keep going. I would do all three. It doesn't matter though. If you mean you're wanting to add these two? That's okay. You could totally do that now, or you could save it till later. I see what you mean. Yeah. Sorry. Yeah. Either one. Either one's fine. Either order. So I break down. I'm gonna do them all first, but you don't have to. So the 12 is 3 times 4. The 4 is 2 times 2. 2 2's in. Out comes the 2. What's left in? 3. So 15 roots of 3 plus 5 roots of 3 minus 2 roots of 3. So there we go. Like terms, 15 and 5 is 20, minus 2 is 18 roots of 3. Is this good? Is this making sense? Let's break them down, 2 for 1, like terms. All right, well, let's go to the messier stuff. I think you. Okay, let's try this one. So 5 root 18 minus 3 root 200 plus 3 root 50. So try that, break those down. So break those down. When you break down the 200, let me do the middle one with you. When you break down that 200, here's the easy way, guys and gals. 100 is 10 times 10. So you don't have to go any further. I would just stop right there. 2 10s in, send a 10 out. It multiplies the 3 that's already out there, minus 30 root 2. Everybody see that? Right? You don't have to keep going. So as soon as you see a matching pair, as soon as you got those 2 10s, boom, ship one out right then. Right? You don't need to break them down 2 5 2 5. You could. It'd be the same answer in the end. So as soon as you see the 2 10s, you see the 100, just think, oh yeah, I got 100. 10 times 10, 2 10s in, 1 10 out. Everybody see that okay? Everybody see what happened there? Then the 10 that came out, multiplied the 3 out there to be 30 in the front, left a 2 on the inside. And then finish up the 5 root 18. 18 is 2 times 9. 9 is 3 times 3. 2 3's in. 1 3 out. 3 times 5. 15 root 2. What's that? Yeah, it's going to be 0. This one's 0. That 2's left over inside. Right? Good to there. And then the 50 is 5 times 10. The 10 is 5 times 2. 2 5s in, 1 5 out. Multiplies the 3 out there. 15, what's left over? The 2. And the answer is 0 after all that work. I mean, 0 root 2 if you want, but what's 0 times root 2 or 0 times anything? 0. It's 0. You don't have to show that step. You can just say it's 0. That means all of this is a fancy way to say 0. We just simplified it all.
So once we find like the square root, say the square root of 2, can we just start dividing the numbers by 2?
No. There's no guarantee the other ones will be the same.
Oh.
It was a nice coincidence, but no guarantee. Yeah. No, you just got to break them all down. Just break them all down and do the 2-for-1 ship out, like we've been doing all morning, huh? Since 10:30. Say good. All right, so they're going to change things a little bit for us now. So, square root of 147 minus the square root of 27x squared. So try that. Those are some big ugly numbers. Let's break those down. 147, I don't know what it divides by. 3, divides by 3. Divide by 3, break it down. Okay, break down that one for this. 3 times, what's that, 49? Yeah. 7 times 7. 2 7s in. 1 7 out. Leaves the 3 in. Minus. 27. 3 times 9, 3 times 3, 2 3s in, 2 x's in, 1 3 left over. Good so far. Are we good? Everybody see what I've done there? I just did the 2-for-1 ship outs. Okay. 2 in, 1 out. So, 7 root 3. Minus 3x root 3. Good to that point. Now, are these like terms? Not quite. They have the same roots, but this one has an x, the other one doesn't have an x. Right? To be like terms, you've got to be matching both in letters and in roots, in everything. It's not. These are not matching completely and totally, are they? Right? They're matching part way and not matching the other way, right? They have the same roots, but one has an x, one does not. So, okay, so what does that mean? Well, it means we can't subtract them. We can't go 7 minus 3 is 4. We can't do that. But what we can do is they both have the same root 3, so we can factor it out. You know what I mean? We can say, look, they both have the same root 3. Factor it out. What does that leave? 7 minus 3x. That's the answer. Does that make sense what we did there at the end? We factored out the root 3 because they both had one. But they were not like terms completely because one had an x, one did not. How we doing? Does that make sense? All is well? Okay, so we have the square root of x to the 5th minus x squared plus the square root of 49x cubed minus 49. Try that. So those need to be factored. Both those need to, whenever they have pluses and minuses like that in there, inside the roots, got to factor them. Everybody seeing that? Pluses and minuses inside the roots you must factor. So factor them in there. Okay, so you factor that. Take out x squared, right? Did you do that? GCF? Let me make that a little bit neater. Take out x squared, right, for the first one. The second one, take out 49. Right, they both have GCF. Good? Good so far? Now, can we do more? Well, what's the square root of x squared? It's 2 in, 1 out, huh? So x comes to the front, right? It's gone. 2 in, 1 out. And same thing with the 49. The root of 49 brings out a 7. Everybody good there like that? So far, so good. Square root of 49 is 7. Square root of x squared is x. Those come to the front, come out. And now, these two terms, they both, can we factor? What do they both have in common? They have that square root of x cubed minus 1, huh? What does that leave in there? X plus 7. And we're done. You could put that x plus 7 on the left or the right. That up here, they're wanting you to put it on the left in the answer key. It doesn't matter. Left side, right side, whatever, same thing. Everybody see what we did in that last time? We factored out the root of x cubed minus 1. They both had it. We good? Is making sense? I feel like I'm always asking you for questions, but nobody has any. All right, so I'm going to make this one the square root of 6 minus the square root of 1. So yeah, this one's tricky. See what you can do. Let me give you a minute on this one. This one holds some more trickery to it. How you doing? Giving you a minute here. This one has some issues. Are you figuring out those issues? This one's tricky. So first off, how about this guy on the right? He's got problems. He's got a root in the bottom. Can't have roots in the bottom, right? You can rewrite that thing. Here, let me rewrite it. As root 1 over root 6. Same thing, doesn't matter, right? Root of the whole fraction, root of top and bottom. You guys okay with that? It's all the same thing. Having a root over the entire fraction or two separate roots, same thing, whatever. Can't have a root in the bottom, right? Illegal procedure. Can't do it. Can't have a root in the bottom. So how do we get rid of that root from the bottom? Top and bottom by root 6, right? I'm not even going to mess with the one on the left. He's okay for now. So what do you get there? Root 1 times root 6 is just root 6. On the bottom, root 6? Plain 6. Everybody okay? Just plain 6 on that. See how the root vanished on the bottom? I multiplied top and bottom by root 6. 2 6s in on the bottom, 2 6s in, 1 6 out. On the bottom, right? The 2 in led to 1 out on the bottom. Good, and on the top it's just 1 times 6, 6. Because we don't have 2 root 6s on the top, do we? We just have 1. But on the bottom we have 2. 2 in, 1 out. Out on the bottom. Good. So we got rid of the root from the bottom. Now, can we combine those? Can we subtract them? Yes, if we get common denominators, right? The fractions. We just got to make the bottoms the same. Well, right now, this one is over 1. Yeah. And how do I times the 6? Whoops. Top and bottom, right? Because whenever we do something, it's got to be with balance, huh? Top and bottom, so we don't change anything. What do we get then? 6 root 6 over 6 minus root 6 over 6. Everybody see that? Everybody see what's happening there? Right, I multiply top and bottom by 6. Right, up here, to distinguish, up here I multiply top and bottom by root 6. That was a root. So that's different. Over here I'm multiplying top and bottom by plain 6, not in a root. Because I'm trying to make the denominators be the same, which they now are. Up here I was multiplying top and bottom by root 6, not because I want to make the denominator the same, I just want to get rid of the root from the bottom. So 2 in made 1 out on the bottom. That got rid of the root from the bottom. But over here I'm doing a totally different reason. Multiply top and bottom by plain 6, not root 6, plain 6, to make the denominators be common, same, because that's the only way you can subtract fractions is if the denominators match. So now we can do it. 6 roots of 6 minus, really 1 root of 6, is 5 roots of 6 over 6. 5 roots of 6 over 6. Does that make sense? Are we done with that one? Yeah. No more root in the bottom. Why can't I cancel these 6s? Different worlds. In the root, out of the root, no interaction. That's it right there. So we were able to get rid of the root from the bottom and then subtract the fractions by getting a common denominator. So that's kind of hard, as both things in it. Getting rid of roots from the bottom and subtracting common denominators like that. How you doing?
Why the square root on the bottom cancels out, because the 6 is the same number.
Right. It's got to be the exact same number twice.
To cancel off the square root.
Just cancel out the square root. Well said.
So that way
That's why it does right here.
okay.
Because whereas there's only 1 up there. Okay. Yeah, you're totally right. Yeah, because I know what you're thinking. You're probably thinking, well, look, there's 2 roots here. Why doesn't that? Yeah, it's different numbers, though. You're totally right. You're right on the track. Yeah, is everybody with her on that? She's exactly right. It's got to be the exact same number twice in the root to come out. That's why 2 in, 1 out. It's going to be 2 of identical things to send 1 out. Yeah. Right, because that's really root 36, isn't it? Right? That's why. See, what is that? That's root 36, which is 6, huh? Yeah, we're just shortcutting that. No, that's exactly right. And then to subtract, we've got to have common denominators. And then we do like terms. 6 roots of 6 minus 1 root of 6 is 5 roots of 6 on that. So this one has fractions, roots, the whole thing. That gets people a lot. I think you might have had enough of math. I think we might stop a little early today. It's our second to last week. You look like you're like math. We're not going to finish this section. And I don't want to do any more and then take 3 days off, and then we'll need to refresh anyway. This is a big difficulty. They get hard at this point. They're more of this kind of stuff at this point in 8.4. So it's like I said, we finished 8.1, 8.2, 8.3. Those will be due on Monday. We'll pick up 8.4 on Monday. We just have 1 week left.